Hi, I'm Dave Raffo, Senior Analyst at Evaluator Group. I'm here with Liqid CEO Sumit Puri, and we're going to talk about how Liqid customers are using their GPU on demand and composable disaggregated infrastructure architecture. Hi, Sumit.
Hey, Dave. Thanks for having me.
So I recently spoke to a couple of Liqid customers for a research report that I wrote and is now on the Liqid site. Sumit, maybe you could tell me, what's Liqid, what do you see as the value prop you look to deliver to your customers?
No, great question, Dave. And one of the things that we've done recently is really refine where we're deploying our technology. And one thing we're finding is the biggest value proposition that we can bring to our customers is increasing the utilization rate of very expensive hardware. And today, there is no more expensive hardware and more power consumption, power-hungry hardware in the data center other than GPUs. So we are narrowly focusing our solution more and more towards GPU-centric workloads. GPU on demand is a service that we are delivering. The end goal of our solution is to be able to change the economics of how we deploy these things. So whether we're scaling them, whether we're sharing them, or whether we're building very high-performance systems that run AI really fast, really our value proposition is around changing the economics of how our customers are deploying these accelerators.
So, in the early days of Liqid, you may have been the first, certainly one of the first, to talk about composable infrastructure. And, you were looking to improve the utilization of a lot of different resources. Are you not seeing demand for that? Is it all GPU, or is GPU just the most popular among those resources?
Yeah, no, so our platform still remains very capable of supporting all the different device types, and so that remains a focus. Whether we're doing FPGAs, GPUs, or storage, or Optane memory, our platform can encompass all of those solutions. But the reality is where we're finding the biggest pull, the biggest traction for our solution is in the areas where economics matters. And there's a lot of money that's being spent towards AI-centric workloads like ChatGPT, and people are trying to find ways to change the economics of that, and that's a solution that we're bringing forward. So GPU is our primary focus, but we retain the ability to support all those other device types.
Yeah. So, the customers I spoke to, they all, they had different use cases, but they agreed that, the Liqid technology is helping them improve in areas like, management efficiencies, cost, performance, and sustainability, mostly around GPUs.
Yeah, I think those are very typical. I think there's kind of four primary areas where we see a lot of traction. First, I would say, is around HPC. We see a tremendous amount of pull towards GPUs and HPC environments. If we think about HPC, different researchers bring different workloads to the supercomputer. Different workloads require different hardware profiles. We can study the workload on the inbound, spin up the machine size as we need, get the work done, and then free the resource out to other machines after the work is completed. We see a lot of people building dynamic clouds, right? Clouds to service their internal customers, like UIC is doing, where they're building an internal GPU cloud to service their internal researchers. They want the flexibility and agility that they would have gotten on something like public cloud, but they want to save money and reach higher levels of performance. We see a lot of pull in media and entertainment. They consume large quantities of GPUs and high-performance storage, and that includes the gaming developers, right? And so that's another area where we think we can make an impact. And to me, maybe the one area that's most exciting is really around edge. And so we see a convergence of GPUs at the edge, because edge is where all the data is generated. And so eventually we want that data to reach the GPUs very quickly, and so we're going to put the GPUs closer to the point of data origination, which is at the edge. And at the edge, we're limited by power, floor space, cooling, human access, and those are the exact issues that we are fixing with our composable architecture.
The system architect from the genomics lab told me that, he was really impressed with Liqid's ability to let him dynamically allocate resources on the fly. His quote was, they're doing, Liqid is doing hands-on, different than what anybody else is doing. And this is a guy with, like I said, several high-performing NAS file systems and petabytes of data, so it's a pretty sophisticated operation.
I think when we invented virtualization and we created the ability to share compute, we fundamentally changed the way we deployed compute. When we invented things like network-attached storage and made storage shareable, we fundamentally changed the way storage was consumed in the data center. I think for GPUs, it's going to be no different. When we figure out, and which we are doing today, how to make these things a shareable element, I think that is the only logical way that we are going to share these things inside the data center. The cost and the power that these things are requiring now, putting 1 or 2 in every box and deploying a bunch of boxes, that's not the way that we see the future happening. And so we're excited to continue to innovate on this front. I think the most exciting for us is we continue to evolve. PCIe Gen 4 will give way to PCIe Gen 5. We have emerging interfaces like CXL that are coming, and Liqid's vision is to be a multi-fabric orchestrator where we can orchestrate across a large variety of interconnects, PCIe, Ethernet, InfiniBand, CXL, and we want the ability to support all the device types. So GPU is the focus today, but memory is coming and storage remains important.
You know, on the interface side, what are you seeing? Are you seeing any of them, getting more play than others? You mentioned several different kinds of fabrics and interface. What are people using it for now?
Yeah, so I think the way the world eventually plays out is every server is composable. Every server can change the amount of hardware connected to it, but it's going to be which fabric type do we choose. So there will be an Ethernet connection, and it may make sense to grab my storage over Ethernet, because that's very logical. But then there will be a low latency connection, something like PCIe or eventually CXL, because I want to grab my accelerators or memory over that low latency thing. And so we think CXL is going to be critically important. We think PCIe 5 remains critically important. And we think Ethernet and InfiniBand remain critically important. It's really the right tool for the right job. And that's where we're focused, is the ability to orchestrate across all these.
So the important thing is to cover all bases, no matter what you're using, where you are,
That's
where
right.
they are, you can cover them. All right, well, thanks for watching. You can download my report from the Liqid website on the user use cases. And we hope to speak to you all again soon.